Good morning, students. Students, good morning.
Good morning, sir.
So how is new laws of motion going? Friction, is everything clear? Any doubt? Any problem? Tell me. Any doubt is there? Any problem is there? Ask me, because possibly this Sunday, that means coming Sunday, we will have exam on laws of motion and friction. Okay, there will be online exam for you. Are you ready for that? Tell me first, ready for that? Say yes or no. Yeah. So comfortable, no? There is no problem? Okay, fine. If any problem anywhere is there, you will be asking me, because so far I have not got any kind of questions from you people that you have a doubt in it. Okay, even worksheet or otherwise also. So I feel you are very comfortable and you will be doing well in the test also. Am I correct?
Yes.
Okay, great. So see then, in friction, in the last class we studied about what is going to be the resultant force, resultant contact force. What will be its value? What is its minimum value? What can be its maximum value? And we also studied that whether pushing is easy or pulling is easy last time. So pushing is easy or pulling is easy? What we got? Tell me. What is easy? Pulling is easier than pushing. That's what we found out. So similar way, I am asking one more question from you. That's a question based on whatever we have done. There is this box is there, which is placed on a friction surface with a friction. Coefficient of friction here you can say between these two, we'll say is mu. Coefficient of friction is mu. Okay, and I'm applying the force in this way. Let this be theta. Okay, and the question asks us, find what is the minimum value of force. What is the minimum value of force required to move the block? Required to move the block. Okay, that's the question. Right. Note this one. We'll see what we can do for this. What is the minimum value of force required to move the block? Done? Completed? Noted the question?
Yes, sir.
Okay. So see what we can do. First thing, as I told you, if you remember, I told you whenever minimum or maximum is coming in question, immediately your mind need to go back that there is somewhere we have to go for the minima or maxima of differentiation. We have to go for it. So that means differentiation is required in it. Okay. Whenever minimum or maximum is coming, that means differentiation is required. Okay. So we'll see what we can do. So this is the question here. Minimum value of force required to move the block. So now what we can do in this, first of all, we are going to resolve this. Resolve the forces. We know it is having two components because this is inclined force. Okay, so horizontal component adjacent to theta means F cos theta, and the other component is F sin theta. Then you have mg here, and there will be normal contact force upwards. And then there is friction. If you are trying to move it in this direction, friction will be acting in opposite direction because it opposes the sliding. So friction is opposite. Okay. Now, if I want to move this block, that means the force towards right. Who is the force towards right? Only F cos theta. And force towards left is force of friction. So if you want to move this F cos theta, at least need to be greater than force of friction, then only it will move. Right? For moving the block, F cos theta need to be greater, or let's say equal to also force of friction. Right? This is the condition. Now, force of friction is which force of friction? You are trying to move it. Still, it is not moving. It is at rest only. So, which friction it is? Kinetic friction or static friction? Static friction. And static friction also which one? Limiting one. Because you want to move it. So, move it means you need to apply the force which is greater than limiting friction. So, this is limiting. If it is limiting, then I should be writing it as F cos theta should be greater or equal to mu n. Mu n, that is the limiting value. Now, what is n in this diagram? Let's say mg equal to n plus f sin theta. Mg equal to n plus f sin theta. Why we can write like this? Because we know that there is no motion vertically. Vertically, it's an equilibrium. So, n plus f sin theta equal to mg. So, n is what? N is mg minus f sin theta. We'll put in this one. So, then what is coming? F cos theta is greater or equal to mu mg minus f sin theta. Okay, is it over? No. Why? Because f, here also f. How can f be in terms of f? So f, you bring it over here. This f, we'll be bringing here. Okay, let's see. So f cos theta, and here is minus mu f sin theta. Bring it here, it will become plus. So plus mu f sin theta greater or equal to mu mg. Take f common from here. Take f common, it becomes cos theta plus mu sin theta is greater or equal to mu mg. Then what is f? F is mu mg by cos theta. One second. This is greater or equal to mu mg by cos theta plus mu sin theta. And this is force. That's all. Question is over? No. Because we want minimum value of force. This is force in terms of theta. What is minimum value? For that only we have to differentiate it. Okay, so first note it. If any doubt is there, please ask me. Any doubt?
No, sir.
Okay, note this. Done?
Done, sir.
Okay. Now see here, f is greater or equal to mu mg by cos theta plus mu sin theta. Now, if you want this minimum, what should be in this denominator? Should be maximum, minimum, or 0? If you want this to be minimum, this denominator should be maximum, minimum, or 0. Think and tell me. Take your time.
Maximum, sir.
Maximum. Okay. So we'll write that because it's very simple actually. If I say I am writing this as f equal to 1 by x or 3 by x. Now, if I want minimum value of this, so for minimum value, suppose we have values from 1 to 10. First I kept 1. What's coming? 3. Then I kept 10. And it's come 0.3, which is less. This is less than this. That means greater the denominator, lesser the value. Lesser the denominator, greater the value. Okay, so here also we want this denominator to be maximum, right? So we'll go for that. So I'm writing for f to be minimum. This denominator cos theta plus mu sin theta should be maximum. Okay, for the time being, I'll assume that this is x. Cos theta plus mu sin theta is what? X. Now, x maximum value we are calculating. So, see then. Okay. So, we are calculating maximum value of x. So, what to do? You do dx by d theta. Why theta? Because here function is in terms of theta. So, differentiate it. And then do what? Equate it with 0. That's it. So, let's differentiate. Say d by d theta of cos theta plus mu d by d theta of sin theta equal to 0. So, d by d theta of cos theta is minus sin theta. So, minus sin theta plus mu d by d theta of sin theta is plus cos theta. Okay. Take sin theta that direction. Mu cos theta equal to sin theta. And cos theta will go there. So, mu equal to tan theta. That means if tan theta equal to mu, then our force is going to be minimum. Okay. Or cos theta plus mu sin theta will be maximum. All right. Note this one. This you remember, okay? This mu equal to tan theta. Completed?
Yes, sir.
Okay. So now let's put the value into this one because we wanted the value of minimum. So let's put in this value. Okay. So what to put? we will be putting cos theta and sin theta value. So if tan theta equal to mu, what is sin theta value? Very simple. How to find? Make a triangle. Say this is theta. Now tan theta is mu, that means tan theta equal to mu by 1. So that means this is mu and this is 1. Because tan theta is opposite by adjacent. So mu by 1. So what will be this then? This is hypotenuse of this triangle. Hypotenuse square means this is square plus this is square. So hypotenuse means what? Root over mu square plus 1. This is the way we should find out if we have tan theta or sin theta or cos theta, whose the value we have. Then we can find out remaining trigonometric ratios by making right angle triangle. Okay, so what's sin theta? Sin theta is mu by this. So mu by root over mu square plus 1. What is cos theta? Cos theta is 1 by this. Cos theta is 1 by root over mu square plus 1. Now let's put it in this one. Okay. And this we are removing. All right. So F minimum. Now F minimum I'm writing directly should be equal to mu mg by cos theta, that is 1 by root over mu square plus 1 plus mu into sin theta, which is mu by root over 1 plus mu square. Okay, then you can see that here and here the base is same. So what will happen? We can write 1 plus mu square, mu mg by 1 plus mu square by root over 1 plus mu square. Okay, then what are we going to do further? And simplify that. So simplification means this will be mu mg. This I can write as root over 1 plus mu square whole square by root over 1 plus mu square. This and this gets cancelled. Our answer is mu mg by root over 1 plus mu square. This is the minimum force required to move the block. Did you understand? Is this clear?
Yes.
This also, if you can remember, that will be great because they'll be asking you this question. So if we are going to do it, it will take time. You saw that. We took long time. But if you remember that, it will be great for us, like a formula. So minimum force required to move the block is mu mg by root over 1 plus mu square. Come on, note that. Completed?
1 minute, sir. done, sir.
Okay. Fine. Let's do another type of question. Suppose here is wall. This is a wall. And there is one block. Okay, block of mass, let's say 10 kg. Okay, coefficient of friction between this and this is 0.4. Question is asking, how much force shall we apply so that this block can be at rest? Okay, find the minimum force required so that block can be at rest on the wall. Okay, right question. Completed?
Yes, sir.
Okay. Tell me, what shall we do? In this one, first of all, we have to find out that what are the forces which are trying to move it. So which force is trying to move it? Can you tell me? Which force actually is trying to move it? Is force that I applied, F, is it trying to move that? Say yes or no. Is this force trying to move it?
Yes.
No, not trying to move it. Then which one? Let me take the example. If I say this is a box, can you see that? Is it visible to you, this box?
Yes, sir.
We make it possibly slightly lighter, this one. Okay. Very bright, but okay, just to see that, okay, I'm not doing anything on this. This is the box. Okay, and this box, I'm going to place it on the screen like this. So the question is, which force is trying to move it? Gravitation is acting downwards. Okay, and the force applied by me? Force applied by me is like this. Okay, this is F. Is it trying to move it? No, not trying to move it. It's just compressing this box towards the wall. Which force is trying to move it? It's weight. It's weight downwards. Okay, that is trying to move this block. Okay, so which force is trying to move it? It's mg. Where is mg? Downwards. So put it here. This is the force which is trying to move it. Then which force will stop it? Why? Because there is a contact between the two. So friction force, which is acting in this direction. It will act opposite to the force which is trying to move it. Then, what about normal contact force? Normal contact force is here. That's all. Okay, so then if you want to stop it, my friction force at least need to be equal to this. Then only we can stop it. So minimum force of friction required is how much? 10 G. To stop. Okay. Then what about force and normal contact force? What is the relation? F and N are equal. How? Because they are not moving in this direction. They are in equilibrium. So F equal to N. So you want to stop this one at any cost. And that means force of friction will be maximum. Limiting. So if limiting force of friction, then I can write force of friction as UN. So put it here. This value. So mu N equal to 10G. But what is N? N is actually F. So mu F equal to 10G. Mu value 0.4 is F equal to 10G means 100. So F equal to 100 by 0.4. That will be 1000 by 4. That will be 250 Newton. So if you apply 250 Newton from here, then only you can stop this block. Is this clear?
Yes, sir.
Okay, note that. Completed?
Done, sir.
Completed now?
Yes.
Okay. Similar question I am giving you again. One more. Okay. So it'd be like this. Yeah, move it a little. Not like that. Inside motion. Okay. Suppose this is wall. Okay. On the wall, I am making one box here. There is a box like this. Is it visible to you? I think it's not visible. Okay. Where it is. We have to. Okay, in this one itself, I'll make it. Then with white color, it will be good. So this is actually a wall. Okay, and on this one, I'm making one box. Where's the box? Okay, on this box now, its weight is there. Its weight is W. W is, let's say, okay, let's say 10 kg. Okay, from this side, I'm applying one force. Right, its magnitude is also 100 Newton. Friction is there between wall and this box. Mu is 0.4 or 0.5. Okay, we have to find whether this box is going to move or not. If it is going to move, then what is its acceleration? Okay, find, will this block move? If yes, then in which direction? Then in which direction? And what acceleration? Okay, one more force is there that I forgot to apply on that one. That force is perpendicular to the wall, like this. Okay, so I'm making it something like this here. This is perpendicular to the wall. Okay, how much that is? Maybe I'll make it like this, so that it looks like it's perpendicular to the wall. Okay, this is perpendicular to the wall. This force is 50 Newton. 50. Now we'll make it as 120 Newton. Okay. So from this side, how much force is acting on this one? 120 Newton, like this. Okay. So that's your question. First, make the diagram. Completed?
Yes, sir.
Okay. Let's solve then. Let's see what is happening. This thing I'll remove because we require the place. Okay. So first thing is, what we are going to do, we are going to make the box again. Okay, this is the box. Right, we can make three-dimensionally. Let's see, is it going to help us? Okay, now in this one, we know that gravitation force is acting downwards. Weight is 10 kg. So this is downwards. There is 10 kg means 10 G, which is 100 Newton, is acting like this. And there is one force which is acting from the left, like this. That's 100. So this force is also trying to move it. This force is also trying to move it. So where it is likely to move? Resultant of both. Okay, what is resultant of both? You see, this one here, if I can remove its direction. Okay. Okay. So then this is how this is moving. Okay, this is trying to move it in this direction. This is trying to move it in this direction. So where will be resultant? Resultant will be here. So it will try to move in this direction. Okay. Who is going to prevent it? Friction. Where will friction act? Friction always acts opposite to the moving force. Which is moving force? This 100, or resultant? Resultant. So friction will be acting this direction, remember. Now the question is, what is friction? Friction will be mu n. But what is n here? Because this is not acting perpendicular to the wall. Wall is behind. This is the wall here. Okay, this is the wall. Where is the wall? This is the wall. This here. This. Okay, that's the wall. This is the wall. This is the wall. Okay, so how we have to act the force? Force need to be perpendicular to that. And which force is perpendicular? This 120. Okay, which force is perpendicular? 120 Newton. So 120 Newton is acting like this, directly on this one. So what will be N value? N value will be 120 only, as we saw that. Okay, in the previous question. What force you are applying? You are applying it like this. So normal contact force will be opposite to that. Okay, so normal contact force value is what? 120 Newton. The normal contact force is 120 Newton. So what is limiting force? Limiting friction is mu n. Mu is 0.5. So 0.5 into 120, that means force of friction is 60 Newton. So 60 Newton is acting over here. And what is this resultant? This is 100, this is 100. Okay, this is 100, this is 100. So the resultant will be what? We have to find. Okay, so resultant will be this, both are perpendicular to each other. So resultant will be what? Use the parallelogram theorem. So what it says, R squared, resultant square, will be equal to this square plus this square, because they are perpendicular. Otherwise, what is the formula? Otherwise, formula is F1 square plus F2 square plus 2 F1 F2 cos theta. This is the formula of the result. Okay, let's put it. So if we are putting it, we are getting F1 square plus F2 square, because angle between them is 90. So cos 90 is actually 0. So this term becomes 0. So R square equal to what? F1 square plus F2 square. That means 100 square plus 100 square. Because this is also 100 and this is also 100. So what is going to come? What is R value? R value is, now this is R square. So R means this. So this is 100 square plus 100 square. From this 100 square, we can take outside, take it common. So when you take 100 square common, it will come out of the square root, it will become 100. Inside is 1 plus 1. For this one, this one. So what we are getting? 100 root 2 Newton. So R value is 100 root 2. Friction value is 60. So what we'll write for final acceleration? R minus force of friction equal to mass into acceleration. So this is 100 root 2 minus 60 equal to 10A. So A equal to 100 root 2 minus 60 by 10. This 0, and this 0 cancel. So our acceleration is 10 root 2 minus 6. If exactly we have to find, then root 2 value we can keep 1.414. 1.414. So this will be 14.14 minus 6. That means 8.14 is your answer. 8.14 meter per second square. Is this clear?
Yes, sir.
Okay, note that. Completed? Is it over, students?
Done, sir.
Okay. So let's move for the next question then. Okay. See now. Another one. So here is one box. And with this, there is one more box attached. Its mass is m, mass is small m, and coefficient of friction between these two is mu. This is smooth, so there is no friction. Okay, question is asked from us. What should be the value of F? What should be the value of force F so that small block does not move down? You have to prevent it from sliding downwards. That's the question for you. Note it. Done?
Yes, sir.
Tell me what to do. What shall we do? How this force is going to make sure that this is not coming down? How this force is going to stop it? Any idea?
Sir, the body is not in acceleration.
Which one?
The body is not in acceleration.
Yeah, but if it is not in acceleration, how will you stop it? It will not stop, no. Because it will come down. Friction will not act on it if it's like this. Because how we are going to glue it here? Not glued. So it will come down. But you have to stop it from coming down. What shall we do?
Pseudo force.
Sorry?
We have to use the concept pseudo force here.
Yes. You have to use pseudo force. Because you want this to not move with respect to this. It should be addressed. So we have to make it move. If it moves, we know that its acceleration will be like this. If its acceleration is like this, on this one, pseudo force will act. What is that? MA. And this MA is only going to give a normal contact force. Okay. So how to do that? First of all, F is going to make in this entire body, M as well as small m, to move with acceleration, let's say A. F will be equal to the total mass into acceleration. The acceleration is F by m plus m. Right. Now, what we got over here, we said that on this one, because of that, pseudo force will act, which will be equal to m. And what we have to do? We know that in this direction, mg is acting. Who is going to stop mg? Friction. This is here. Friction has to stop mg. Right? So what we want, since you have to stop it, let's take its maximum value. What is its maximum value? Limiting is equal to mg. And limiting value is what? Mu n. Or if you are not taking limiting also, what we can say? That force of friction limiting need to be greater or equal to mg. Okay. Then what? Mu n should be greater or equal to mg. Then we can stop. If limiting force of friction is more, then you can stop it. Or if it is equal also, you can stop it. What is n value? N value is ma. So right here, n to ma greater or equal to mg. This m and this n we can cancel. Yes. Now a value. What is a value? F by m plus m. Keep it. F by m plus n. What is this n here? This is mu. Mu. This is okay. Greater or equal to g. What we want? F value. So F need to be greater or equal to m plus m into g by mu. When F is greater or equal to m plus m g by mu, we can make this body stop. Did you understand that?
Yes, sir.
Okay, note that. Completed?
Done, sir.
Okay. Let's see another one. Another one is, okay, let's take a truck. There's a truck here. Okay. And on the truck, there are certain boxes kept. Boxes mass, you can say 10 kg. Okay, and the length of this, let's say, is 50 meters. 50 meters will be too much, right? 5 meters. Okay, length of this is 5 meters. Okay. Coefficient of friction. 0.4. And acceleration of the truck. Acceleration of the truck is 4 meters per second square. Hmm. Five meters per second square, not 4. 5 meters per second square. Okay, now question is, find how much time box required to move out of the truck. Move out of the truck. Find how much time box required to move out of the truck. Note the question. Noted the question?
Done, sir.
Right. Tell me then why this block should go out. Why this box has to go out of the truck? And which direction it will go out of the truck?
Left side.
Left side. That means back side. Why it should go like this? Which force is acting?
Pseudo.
Which force is acting on it?
Pseudo force.
Pseudo force. Because frame is accelerating. So frame is accelerating. With respect to the frame on this box, pseudo force will be acting. Which direction? Backwards. So how much pseudo force will be acting? Pseudo force value is m into a. Mass is 10. Acceleration is 5. So 50 Newton is acting. Who is going to stop it from moving? Friction. The friction will be acting here in this direction. Right. Now we have to see that whether it's more than limiting. This 50 is more than limiting or less. If it is less than that, it will not move at all. Forget about the question. We will say that it will not move out. But if it is more than limiting, then it will move. So what is limiting value? Mu n. Limiting value mu n. Then n is what? There is mg. Here is n. So n is equal to 10g. Okay. So see then mu is 0.4 and n value is 10g. That means 100. So 100. What's coming? 40. This is 50 here. This is 40. That means this is going to move. With what acceleration? We can find. We can say 50 or pseudo force minus force of friction equal to mass into acceleration of the block. A I am not writing because A already we have taken it. The acceleration of the block, which will go like this. Okay, so pseudo force 50, maximum friction force 40 equal to 10 into acceleration of the block. So this is also 10. This is also 10 here. So acceleration of the block is coming 1. Is this the answer? No, because we have to find in how much time it's going to travel this 5 meters. How much time it will be traveling 5 meters. So then what shall we do? Equation of kinematics we will use. Why kinematics? Because acceleration is constant. This is given constant 5. So this is also will be constant 1. Okay, so what is the formula? Formula says S equal to ut plus half at square. This is what? 5. Initial velocity, we take 0. We'll take 0. Why 0? Because when it starts with 5, at that point itself, this has got the motion in this direction. Okay, as soon as it starts. So as soon as it starts means before starting what it was doing. It was at rest. So u is 0. Acceleration of the block is 1 into t square. So 5 equal to 1 by 2 into 1 into t square. That means this is 5 into 2, 10. So t square equal to 10. So that means t equal to root 10 seconds. That's our answer. Is that clear?
Yes, sir.
Okay, note that one. Completed?
Done, sir.
Okay. So let's move on to the different type now. Different type means let's take an inclined plane. This is inclined plane. On this inclined plane, there is one box with mass is m, and coefficient of friction is mu. Okay, coefficient of friction is mu. Now we have to find if this block is coming down, with what acceleration it will come down. Acceleration with which block will move downwards. Will move downwards. Okay, we'll see. Oh, what we can do in this one? Let's find out that first of all, what force is acting in this direction, because in this direction only the block will move. We all know that mg is acting like this. Okay, if mg is acting like this, then what will be this? This is mg sine theta, because this angle here is 90 minus theta. Adjacent to the angle is cos component. So mg cos 90 minus theta, which is mg sine theta. So this is mg sine theta. In this direction, mg cos theta. Here is mg sine theta, here is mg cos theta. Then normal contact force. Where is normal contact force? Here. Then there will be friction. Where will be friction? Friction is here. All the forces we have shown. Then if at all acceleration is there, it will be like this. So tell me, is the free body diagram that I have made is clear to everybody? Any doubt?
No doubt, sir.
Okay. So it's acceleration A when I am writing. I'll see that this is the force herein, which is trying to move it, and this is the force which is trying to stop it. So we can write mg sine theta minus force of friction equal to mass into acceleration. What friction will take? Limiting. If it is starting from rest. If it is already in motion, then kinetic friction. And in this case, both are equal because only one mu is given. So mu s, mu k, we have to take as mu only. Okay. So let's write mg sine theta minus mu n equal to m. So here is mg sine theta minus mu. Now n value is what? N value we can see is mg cos theta. Right, mg cos theta equal to ma. So here m, we can cancel. Okay, so what we get acceleration is g sine theta minus mu g cos theta. Okay, note that one. This is the acceleration with which block will move downwards. Completed?
Yes, sir.
Okay. Let's continue with this. See the same inclined plane. Same box, same friction. Okay, then I want to push it up. The question asked, what is the minimum force required to push the block upwards? Push the block upwards. Okay, note this and try and solve. Try and solve and tell me what will be the answer. Come on. Come on, tell me, what is the answer coming? The timer I will start. How much time you want? 1 minute. The timer starts. If you have completed, you tell me. No need to wait for the timer to complete 1 minute, okay?
Sir, force will be greater than or equal to mu mg cos theta, sir.
Say again, F equal to?
Mu mg cos theta.
No. No. Okay, see on the board. First thing is make free body diagram. From there, answers will come. Make free body diagram. So, free body diagram says mg is acting here. Okay. Then components of mg. In this direction, mg sine theta. In this direction, mg cos theta. And in this direction, n. Now, if you're trying to move it upwards, where will friction act? Downwards. So, friction is also acting down. Now, tell me, if you want to move this, you need to apply the force more than mg sine theta plus friction. Then only it will move. Otherwise, it will not move. We'll say that F need to be greater or equal to mg sine theta plus friction. Which friction? Because you want to move it, you need to apply force more than limiting, then only it will move. So F need to be greater or equal to mg sine theta plus mu n. And what is n? N value is mg cos theta. So F need to be greater or equal to mg sine theta plus mu mg cos theta. So F is greater or equal to, take mg common, so sine theta plus mu cos theta. That's our answer. Did you understand? Is this clear, students?
Yes, sir.
So without making free body diagram, never give the answer. Okay. What you thought is, if this is greater than friction, it will be the, that's all. No. If you make the free body diagram, you understand that mg sine theta is also acting in opposite to this force. Okay. So always make free body diagram before giving the answer. Okay. Note it. Completed?
Yes, sir.
Okay. Let's see another one. Same way. This inclined plane, angle is theta. Here is the box. This is m. Coefficient of friction between them is mu. Okay. This time I want to apply the force like this. And what this force is doing? Find force F to stop the box or the block from moving down, from moving downwards. Previous question, we found the force which was required to take it up. But this is saying you have to apply the force to stop it from going down. And how much is that force? Okay.
So mg sin theta minus mu mg cos theta.
Mg sin theta minus mu mg cos theta. Why you did like that? Why not plus? It's similar question to last time, no?
But it is to prevent it from sliding downwards.
Yeah. Again, same thing. We have to make free body diagram. This is mg. Here is mg sin theta. Here is mg cos theta. Here is n. Now the question is, where is friction acting? Let's goes into the question. What it's doing? It is already going downwards. So if it is going downwards, where will friction act? Opposite to motion. So it will be acting upwards. Friction is acting upwards. And since friction is not able to stop it, that's why you apply force F to stop it. That's the question here. Okay. And then what we are getting? Instead that F need to be greater or equal to mg sin theta minus friction. Mg sin theta minus friction. Even if you stop it, the stop it greater will not be there. Equal to we'll say. Because if you have greater, then it will start moving upwards. So you have to stop it. So F need to be equal to mg sin theta minus force of friction. So we know that then now mg sin theta is here minus mu n, that is mg sin theta minus mu mg cos theta is the value of force. The previous question, when you wanted to move it, it was mg sin theta plus mu mg cos theta. Now you want to stop it from coming down, it is mg sin theta minus mu mg cos theta. Is it clear to everybody?
Yes, sir.
Okay. Can I clear the board?
Yes, sir.
Okay. All right. So let's, based on this concept, let's have one question. So 60 degrees. 60 degrees shall I take? Well, then root will come. 60 degree means some root will come in. Okay. And take 37 degrees. And you take this as 53. Here is a 5 kg block. The pulley. And here is also 5 kg block. 5 kg. No, make it something else. Make it 10 kg. Okay. Friction here, the coefficient of friction here is 0.2. And coefficient of friction here is 0.4. Okay. A1, what is the acceleration? Acceleration of the system. Find acceleration of system when it is released. When it is released. Okay, that's the question for you. Come on, note it. Noted question?
Yes, sir.
Okay, let's start then. First, what we'll do? Free body diagram we'll make. You see then, what says free body diagram? 10 kg is heavier than 5 kg. So obviously that will be the giving the moving force. So I'm assuming that this acceleration will be A. That's what we are finding. So in this direction, mg, which is 10g acting. In this direction, 10g sine 53, sine component. In this direction, 10g cos 53. Here is normal contact force. Here is tension. And so is friction here. So if I make the equation for this one, this motion, okay, which is driving force 10g sine 53, opposing force tension, as well as friction. So let's write the equation over here. Equation is 10g sine 53. Sine 53 value is 4 by 5. If you want, you can keep it. So I'm keeping it over here, sine 53. 10g sine 53 minus t minus force of friction. Which force of friction? Mu n. So I'm writing at the moment mu n equal to 10a. This is the equation. Put it in this one, whatever we know. This is 5 2 ja. So 8g. So 8g minus t minus friction. Now friction coefficient of friction is 0.2 and n value we can see is 10g cos 50. Cos 53 is 3 by 5. So 10g into 3 by 5. What is coming? 10g into 3 by 5. So that becomes 6g. So minus, sorry, 0.2 into 6g equal to 10a. The final equation is 8g minus 1.2g minus t equal to 10a. 8g minus 1.2g means 6.8. So 6.8g minus t equal to 10a. That's our first equation. Okay. Then let's go for the other block. What is this? Here 5g sine 37. Here is 5g cos 37. Here is its n, let's say n1. Here is tension. Now the question is, where is friction? Will it be acting downwards or it will be acting upwards? Where is friction?
Downward.
Downwards, because this is going down, so this will move upwards. If it's moving upwards, then friction will be down. Okay, so let's make its equation also. Okay, so its equation is T, because it's taking it upwards, T minus 5g sine 37, 5g sine 37, minus friction, okay, minus friction here. So minus friction, friction what you will write? Mu n1, rather mu1 n1. What is mu here? 0.4. So mu1 n1 equal to 5a. Okay, equal to 5a. So then what? T as it is, minus 5g sine 37. Sine 37 is 3 by 5. So 5g into 3 by 5 minus mu1 0.4. N1 value 5g cos 37. Cos 37 value 4 by 5. 5g into 4 by 5 equal to 5a. This 5 and this 5 cancelled, and this 5 and this 5 cancelled. So what we are getting here? T minus 3g minus 1.2g. 1.2g or 1.6g? 4 into 0.4, 1.6g. Okay. So let's take it backwards. 1.6g equal to 5a. So T minus 4.6g equal to 5a. This is your second equation. This is equation number 2. Equation number 1, equation number 2 we are going to solve. What we have to find? Acceleration. So add both. Both equations we are going to add. So adding equation 1 and 2. Both equations we are going to add. So when you add it, you see that minus t is here, plus t is here. That gets cancelled. So what we are getting? We are getting 6.8g minus 4.6g equal to 5a plus 10a. That is 15a. So 6.8 minus 4.6. How much is going to be there? 2.2, I think. 2.2g equal to 15a. The acceleration is 2.2g by 15. You check that 6.8 minus 4.6 is 2.2 only, no? Acceleration 2.2. G you can, if you want, you can take 10 by 15. So this is 2, this is 3. So 4.4 by 3 meter per second square. Is it clear?
Yes, sir.
Okay, note that. Completed?
1 minute, sir. Done, sir.
Okay, so we'll finish the class today here. That's all. Next class, possibly I'm saying there may be 10 or 15 minutes left for the second class. but mostly we'll finish friction in the next class. Okay. The next chapter, what shall we start? Circular motion or work and energy?
So work power energy.
Work power energy. Okay, so we'll go for work power energy next. But in the next class, most possibly, friction will be over. So you need to be ready for the test. I'm going to conduct the test on Sunday, or whatever we have done. That will include laws of motion, little bit of differentiation, integration in that, and friction. Is that okay?
Yes, sir.
Okay, then. Bye-bye. See you in the next class.
Thank you, sir.